Let's talk about some operations on sets. So we're going to have two sets, let A and B be subsets of a universal set U. And a universal set is a collection of all possible objects. So I'm going to define four operations. The first one is the union. The union of A and B. And the way it's denoted is A union B. Is the set of all elements that are in at least one of A or B. So you kind of just put all the elements together from A and B into one set. Now the intersection of A and B, it's denoted A intersect B. This is the set of all elements that are common to both A and B. So it's only the elements that they share or that they have in common. Then the difference of B minus A. And the way you denote that is just like you would think, B minus A is the set of all elements that are in B and not in A. So you take the elements of B and you remove the elements that are in A. And then finally the complement of A. And the way it's denoted is A with the C here. AC is the set of all elements in your universal set in U that are not in A. Alright, so let's look at an example of these. Let's say our universal set is going to be A, B, C, D, E, F, and G. And then I'm going to define two other sets. Let's say A is going to be A, C, E, and G. And the set B is going to be D, E, F, and G. And I want you to find all of these sets now. Let's find A union B. So basically what you do is you combine all the elements into a single list. And if there's a repeated element, you only write it once. So A, C, D, E, you only write it once. F and G. So that's A union B. Let's now find A intersect B. What elements do A and B have in common? They only have E and G in common. Now let's find B minus A. So you're going to take the elements of B and you're going to remove any elements that are also in A. So I got to take out E and G, so it'll just be D and F. And then the last one we're going to find is A complement. So you look at your universal set, and you're going to remove the elements that are in A. So A complement would be B, D, and F. Let's do one more example using these operations. Let's look at something a little bit different. Let's look at, let's say the universal set is R, a set of real numbers, and I'm going to look at some intervals for my set. So A is the numbers between -1 and 0. And if you wanted to, you could think of these in set notation like this, all the numbers between -1 and 0, not including -1, including 0. And let's say my interval B is from 0 to 1, not including 1. And I want you to find A union B, A intersect B, B minus A, and A complement. So what's nice about working with intervals is that you can represent them with pictures. So let's do that. Let's look at a number line and let's draw the interval A. So -1 to 0. We don't want to include -1, open circle. Everything between -1 and 0, and you do want to include 0. And let's do the same thing for B now. Let's draw the image for B, and you're going to line them up so they're on top of each other. 0 to 1, you do include 0 between 0 and 1, and don't include 1. So now it makes it a little bit easy. Find A union B. You're just going to put the pictures on top of each other. So what would the combined picture look like? Everything between -1 and 1, not including -1 and not including 1. So if I wrote it in interval notation, A union B, it would be -1 to 1. Now let's find A intersect B. Now you're looking for where do they overlap. Well, if I look here at my pictures for A and B, they only overlap in one place at 0. So A intersect B, it's not an interval, it's just a single point. It's just 0, and that's it. So I would write it with curly braces here, and that's A intersect B. Now let's find B minus A. B minus A, you're going to take your picture for B, and you're going to take away anything that's also in A. So I have to take away 0. So B minus A would be 0 to 1, not including 0 or 1. And then finally, A complement. So you have from -1 to 0. And so you're going to shade in the opposite parts. So here, and then you're going to change your circles. So before at -1 it was open, now it's filled in. At 0 it was filled in, and now it's open. So a complement would be, it's really two intervals, so -infinity to -1 union with -1 included, union 0 to infinity. And there's a complement. Alright, and the last thing I'm going to do in this video is define the empty set. The empty set is the set with no elements, and the way we denote it is with a 0 and a slash through it. That means the empty set.